Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to calculate the area of a segment. So I've circled segment, that's the key word today. We should already know what it is and how it's defined, but just to recap, if you have a portion of a circle like that, and if you chop from where the radius meets the circumference to the other radius where that meets the circumference, and you shade in the area that sits between the triangle and the rest of the circumference, that there is what we refer to as the segment. And that's what we're trying to do, is we're trying to figure out how do we calculate the area of a given segment. And the formula, I'm just going to write it at the top here, and we will go through proving it, but the area of a given segment, that is going to be equal to 1/2 of r squared times the angle minus sine angle. And the key thing to note, both of the angle measurements, they relate to radians, like our previous topics as well. So we may need that conversion to work through as well. So I guess the first step is, well, how did we get to that formula? So let's go through, let's change pen colors, let's try and prove that formula with an example. So I'm just going to make up another segment. These are segment, and I'm shading it in there. This circle, that would be the radius, and the other side of that would also be the radius. So the area of this total shape, area of segment, that's going to be equal to the area of the sector, which is the total shape all the way around, minus the area of the triangle that sits in the middle area of triangle. And that would be this portion there that sits there. And hopefully we recall the area of a sector, that is equal to 1/2 of r squared times the angle, and the area of a triangle was 1/2 of AB times sine C. And this sector here, so let's call the angle delta, just because we don't know what it is. And let's start substituting in. So we don't really have anything to do with the first half of the formula. That's already in a radius angle form. But this one here, we've got A, B, and C. We need to get rid of them. So just a reminder, the angle was always referred to as big C, and A and B joined together to make or form big C. So that means A and B, they're both going to be R, and C, that's going to be the given angle. So let's carry on working with that. So 1/2 of r squared delta minus 1/2 times r, which was A, and then we got times r again, which was B, and then we got times sine delta, which was the big C. We then go ahead and simplify and clean up this. So 1/2 of r squared times delta minus 1/2 of r squared of sine delta. And then if you compare this step with the formula, we've got 1/2 of r squared. We've got that come up a couple times. We've got the delta, which is in the brackets, and we've got the sine delta sitting there. So there's the delta and there's the sine delta. So the only real step we need to do here is just factorize. So both of them have 1/2 of r squared in common. And the first half, the area of the sector, that's just got a delta left over, and the second half has got a minus sine delta common. And that there is how we got our formula. So if you go up to the formula up top, you'll see that they match perfectly, and we're all happy with that. So if you haven't got that down, guys, please do. What I'm going to do is I'm going to pause the video, I'm going to clear our working, and we're going to get into two questions. One where we find this area of the segment, and then one where we work backwards to find out the radius when we're given an area of a segment. Okay guys, so we're going to look at two examples now. The first example, we're just going to apply the formula to find the area of a given segment, and then after that we're then going to work backwards to find the radius. So we're trying to find an unknown radius. So let's get into these questions. So we've been given a circle, and there's our midpoint, and from there we've gone out. We've been told the angle in radians is pi divided by 5, and we know that the radius is 7.2 centimeters. And if we go from end to end, we've been asked to find the area of that segment. So let's start off by writing our formula down. So the area is equal to 1/2 of r squared delta minus sine delta. So let's plug in everything. So 1/2 doesn't change. Our radius is 7.2. So that's going to be times 7.2 squared. And then we're going to be multiplying by that pi over 5. So pi over 5 minus sine pi over 5. And then from there, we can plug that all into our calculator, and that will hopefully reveal our answer of 1.06 centimeters squared. And I've rounded that to 2 decimal places. So well done if you got that. Make sure you write that down with all the steps. Hopefully you understand the radius was given to us there and the internal angle also given to us there. All right, the next question, this one will be slightly harder. I'll have a few tricks to it. So we've been given a larger segment. So from there to there, we're trying to find, or we know that the area of this segment, we know that's 14.1 millimeters squared. We've been told the internal angle is 120 degrees. And we've been asked to calculate x, which denotes the radius of that given segment. So I suppose the first step we need to do is we know that these delta signs, they only relate to radians. So we should be looking to convert our degree number to radians. So we're going to go 180 times pi divided by 180. And just to note, the pi is on top because that's the radians and that's what we're trying to aim for. That's going to be 120 times pi divided by 180, which is equal to 2 pi over 3. So that's our degrees in radians. Okay, so we've got the radians. From there, we're going to write down our formula. So the area is going to be equal to 1/2 of r squared delta minus sine delta. We then start that substitution process. The only thing this time around is we're substituting in the known area, and we're going to be leaving the r as an unknown value, in this case x. So the area, 14.1, that's going to be equal to 1/2 times x squared times 2 pi over 3 minus sine 2 pi over 3. From that, we can start simplifying a little bit. So here is a times 1/2, or a divide by 2. Let's take it to the other side as times 2. So that's going to become 28.2. Will be x squared times 2 pi over 3 minus sine 2 pi over 3. From there, let's move all of this over. It's currently a multiplication. Let's move it over as a division. So that means x squared will be equal to 28.2 divided by 2 pi over 3 minus sine 2 pi over 3. From there, you plug all that into your calculator, and I got 22.96, and I rounded that to 2 decimal places. I'm then going to square root that, 22.96, and then x will be equal to plus or minus 4.8. And in this case here, we're going to ignore the negative 4.8 answer because we know our measurement can't be negative, which means x will be equal to 4.8 millimeters, and I've rounded that to 1 decimal point. So hopefully you found this video on segments useful. What we did is we recapped, we wrote down the formula, we proved where the segment formula came from. We then found the area of a segment, kind of the bread and butter question, and then we worked backwards to find out an unknown radius. All right, make sure you get these examples down, make sure you understand them, and then let's get into heaps of practice.